Hi, in this video we are going to talk about external memory versus RAM and where to use B-trees in the main. So let's get started. There are two types of memory: the main memory, the so-called RAM or the random access memory, and the external or the peripheral memory such as the hard disk, CD-ROMs and so on. And it's very important that different considerations are needed for internal and external memory when dealing with algorithms and data structures. Because so far we have been considering data structures optimized for main memory and data present in the main memory as well. For example, the binary search tree, AVL trees and hash tables. But when data is stored in the external memory, then the disk access time is important as well, and it takes much longer to find the right place on disk compared to the main memory. So that's why it's very important to use different approach, because as we have seen for binary search tree, AVL trees, hash tables and so on, we didn't have to bother about disk access time. We have the data present in the RAM and we just have to use it. But here, this is not the case. Okay, so if the main memory is faster, then the intuition is okay, we should use it always. But sometimes the data we want to store is much bigger in size than the size of the RAM. And we don't have other choice but to store the data in the external memory, such as for example for file systems or for databases. Okay, so why does B-tree outperform search trees? Since the height of tree is low for the B-tree, then the total disk accesses for most of the operations are reduced significantly compared to balanced binary search trees. So basically this is the first reason why it's very good to use B-trees for external memory. And the second reason is that data is stored on disk in chunks or pages, blocks or allocation units, whatever we call it, and the disk drive reads or writes a minimum of one page at a time. And it's very important that each node of the tree, I mean the B-tree, is a block of data. This is not the case for binary search tree or for AVL tree or for red-black tree. There we store a single key, a single integer for example, a single custom object. Here for B-tree, we can store an entire block of data, such as for example a chunk of memory or a page, block, allocation unit. It doesn't matter how we call it, it's very important that we can store a block of data in a single node, and that's why it's going to be very optimal to use B-trees. Because to optimize an algorithm for accessing external memory, we should minimize disk accesses and read and write in multiples of page sizes. And this is why B-trees came to be. And this is exactly why B-trees came to be. So it is an important fact that B-trees are not better than binary search trees in the main, because binary search trees are better in the main memory and the B-trees are better when dealing with external memory. Okay, so again, why is it good? Because we are able to store a block of data in a single node for a B-tree. And this is not the case for the other binary trees we have been discussing, such as the binary search tree, the red-black tree and the AVL tree. And basically what's the difference between the main memory and the external memory? That we have the additional cost, the so-called disk access time, and we have to take it into consideration as well. Thanks for watching.